Hello there, I'm Anushnath Purohit, and this is my project on implementing Formula One power unit in the electrical grid. Formula One is a motorsporting event. What it has done that in the recent years that it has changed from being only a petrol event to a electrical power unit event. It doesn't only source its cars through petrol but through electrical powers in different ways. With this project, what I'm trying to do is implement this same thing into the electrical grid so that we can reduce the dependency on fossil fuels and bring in new ideas of generation of electricity, especially in the areas and countries where there is shortage of electricity, and as we know fossil fuels are depleting at an alarming rate. So let's start with this. Right, the as you see, this is a Formula One car. Basically, until now, all we know about car is that these we think of sporting cars as running on petrol engines. But as a matter of fact, this thing has completely changed the world and how we see cars now. Now let's have a look at what are the problems with the brain system and how we can improve it. Now, when you think of wind energy, we know that wind energy is a vast source of energy. Wind energy is implemented highly in Europe, and we see it everywhere. It's a renewable source of energy, but every source has its problems, and so does wind energy. Now, the most important problem which I'm dealing with about wind energy over here is that at a certain place, whenever there is a decrease in wind speed, the the speed of the wind, the blades of the turbine will reduce. Now, this reduction will lead to reduction in the energy produced. What we are doing as of now in the technology use is using electronic converters to generate the maximum possible power uh, by using MPPT technique from the torque generation. Um, we use rotor side and grid side electronic converters for the, the wind energy for the maximum possible generation. Now, what this creates is there are problems due to high frequency harmonics used in those inverters and DC side converters. There are lots of losses produced, and there are issues of voltage sag, swell, and flicker. Moreover, there are also the well, hello everyone. I'm Anushnath Purohit, and this is my project on implementing Formula One power unit in the electrical grid. Now, Formula One is not just a racing car concept anymore. It is a whole new concept. It is an idea of new technology, of bringing in new things. What Formula One has done since 2013 is change from those traditional V8 and V12 engines which used to be filled with petrol. Now they are generating power in six different possible ways for running their car. That is something massive. What I'm trying to do with this project is implement those same techniques for generation of electricity in our electric grid. This is especially for the countries where where the price of coal and fossil fuels is very high. Therefore, it is important that we find new ways of generating energy. I am trying to implement the idea of Formula One technology into wind and thermal energy sources for a better tomorrow so that our dependency on fossil fuel decreases to a large amount, and moreover, we always have electricity. Now, let's talk about wind generation. Wind generation is a huge source of generation all over the world. It has expanded miles, and the new technology is fantastic. For wind generation, whenever the speed of wind decreases at a certain place, we use power electronic converters on rotor side and stator side, which converts, let's say for in the modeling time, ABC reference frame to DQ reference frame, and that is used to control our active power into the grid and reactive power into the grid. Moreover, the power converters used through the maximum power point technique, they generate the maximum available power and the torque which is produced in the wind blades. Now there is one setback of this. This all sounds very extremely fantastic, but this has some disadvantages. These inverters work at extremely high frequencies in terms of kilohertz. These presence of high frequencies creates harmonics. These harmonics are especially felt in the distribution systems because presently, as you know, most of the distribution systems are predominantly radial. That is, power flow is unidirectional from the generation to this transmission to substation to the load. Now, at high penetration levels, when wind generation can penetrate high levels, the system is no longer strictly radial, and power flow at any point in the distribution system can be bidirectional. This problem can lead to issues like voltage sag, sudden drop in voltage, voltage swell, sudden rise in voltage, and flicker in voltage. All this is because of change in wind speed and the high frequency harmonics used in the power converters. Moreover, there can be islanding and safety issues, protection coordination and high fault current issues, and power quality issues. What we are trying to do with this project is overcome all this with the help of magnetic motor generator units used in Formula 1. Let's also have a look at thermal generation. Thermal generation is the biggest source of generation all over the world. It looks all good, and we all know it creates a massive, massive amount of pollution. That's why my main aim is to reduce that pollution and noise in thermal generation. And let's say whatever little pollution will still have, trying to reduce those carbon emissions, will still have those pollution. I'm trying to generate the energy from those pollution. As you can see from my boilers, you can see steam coming out in the image above. I'm trying to do is generate energy from those steam as well. Alright, let's have a look. In Formula 1 technology, there's this new technology which has come up, which is nowadays also used in few of the road vehicles. This is known as motor generator unit kinetic. Now, what motor generator unit does is that whenever in a car, in a Formula 1 car, whenever the driver brakes, the energy is the mechanical energy generated, which is the heat energy, is converted to electrical energy. The same thing if we try to implement in wind energy, whenever the speed of wind turbine decreases due to reduction in speed of wind around, the the lowering of speed of those blades can be will generate mechanical energy. We are trying to use that heat energy produced to be converted into electrical energy, which can be used now or later. Now let's see how this is done. MGUK. It is a system that converts mechanical energy involved during braking of change in wind speed into electrical energy. Now, this MGUK I'm trying to connect to the drive shaft or the wind turbine through a motor generator set. So, whenever the turbine moves and the kinetic energy of heat produced during braking of wind turbine due to low wind speed is converted to electric power. When the wind turbine is lowering its speed, the generator will store its energy by acting as a highly resistive force. Therefore, low amount of force would be needed during braking as the energy will be stored, like the idea of regenerative braking. This provides less work to be done during braking and dissipation of less heat. Now have a look at the process. In this image, I've shown you an MGUK unit by Magnetic Mirelli, an Italian company which produces this technology for Formula 1 cars. Now, in my grid, the MGU will be connected through continuously variable transmission and a small clutch. Now, why I'm using this? The variable transmission will be used so that for the generation of energy, the MGU can maintain a constant high rotation speed of the wind turbine to utilize maximum braking energy when the wind speed decreases. This is the same process as the MPPT used in the power converters presently, but only with no high frequency harmonics. The clutch used should be for when this wind speed is increased. Let's say the wind speed suddenly increases, the clutch would be de-engaged and let the energy generation be done normally, which is done now. Move the wind turbine, mechanical energy, convert it into electrical energy. Moreover, this energy through MGUK, I'm trying to store in an energy storage system in the form of batteries or a flywheel to store the energy during braking before being sent back to the motor to work. And now, the story of energy is an important concept, and I'll come back to it later in my slides. Let's have a look at thermal generation. In Formula One cars, they've used a special technology because of the pollution of 100 kg of fuel used in each of those 2022 cars in Formula One races. This obviously there's a lot of pollution will be generated, even though how good your fuel consumption is. So what they do is they use a motor generator unit and put it in their radiators, which which is used to generate energy. Now think of it this way: Formula One cars, we think of it as petrol head. It is generating energy from braking as well as from pollution. So why can't we implement this on a grid? Let's see how this can be done. What MGUH will do, it will capture exhaust heat from thermal generating units from the fossil fuel, generating large amounts of pollution and convert it into electrical energy. It can also be used to control the turbocharger to match the grid requirement by slowing it down in place of exhaust gate or accelerating it to compensate for turbo lag. Let's see what we are trying to do with this. Now, a turbocharger is an energy recovery device that uses waste exhaust energy to drive a single stage exhaust turbine to drive compressor through a shaft, which increases the pressure of the inlet charge. So the idea is it will use the waste exhaust and will drive the compressor to generate more energy. Now the compressor will draw air from outside, as you saw from the image before, and compress it before it enters into the intake at increased pressure. This is the same idea as used in air condition, but only now we are using it in electrical grid. Now this would result in a large amount of air entering the cylinders on each intake stroke of our synchronous machine. The power needed to spin the centrifugal compressor is derived from the kinetic energy of the machine's exhaust gases. So the steam generated would be used to spin the compressor, and kinetic energy generated which will be converted to electrical energy. Until now, what we are doing in our conventional system is the exhaust gate, as we saw in that image. The pollution is allowed to vent out excess exhaust from the process. Now let's see how the entire process will take place. In thermal system, the machine uses the available source of fossil fuel as of now. The MGUH, which will be acting as a generator along with the turbocharger, will recover energy from the exhaust and transfer it to the MGUK. The MGUK connected to the machine shaft will act as a motor and store power. So think of this: from the pollution generated, we are generating energy using the turbocharger. This turbocharger and this energy generated is being sent to motor generator unit kinetic, as we saw for wind speed, and we can store power from that, which will come to later. Now, as of now, when load on the grid increases, there is a difference between the mechanical and electrical torque generated, and leads to change in frequency. With our system, when the load on the grid increases, the wind turbine can be used as a distributed source of energy. And the MGUK, with its stored energy, will act as a generator and recover energy from the braking event due to change in synchronous machine's speed. Under braking, the rotational speed of the machine drops, obviously, of the synchronous machine, which can lead to turbo lag. To avoid this lag, by turbo lag I mean is the difference in synchronism between the stator and rotor. Now to avoid this lag, the MGUH will act as a motor for a very short time to instantaneously accelerate the turbo to its optimal speed. That is, the change in speed, the difference speed between stator and rotor will be minimized by MGUH. So this energy will once again power MGUK or be stored. So it is the same concept as synchronous machine using damper windings and reducing the oscillations. But again, we are using it with several sources of energy, not just the fossil fuels. these are the images of the process. Now on the top left, as you see, are an electric motor generator which is used in Formula One car. The turbocharger, the compressor, the turbine. From the exhaust, the steam goes out. The turbocharger gets this inclusive of compressor and turbine, will take out the steam and also vent excess air from outside, like an air conditions, and convert this to energy. On bottom left, you see an assembly of MGUH as a steady unit, the same as the image above, but only a real part. So let's have a look again the entire process. Now, hot exhaust from the machine instead of engine in our case there will be the fossil fuels and thermal generation will be given out to the boilers. Now, this using the turbocharger and compressor will generate energy and charge the battery using MGUH, the electric motor generation. Again, the turbocharger also needs some energy for the compressor and turbine. This energy will generate from the batteries or flywheels used. Again, this amount of energy is very less as compared to what we are generating. Let's have a look at the energy storage system which are currently in use. Now, there can be several ways of storing energy, but I've specially used two concepts because they are prevalent, and I'm trying to make use of them in the grid system. The MGU generates an AC current which is converted to DC to allow this energy to be stored in the battery, lithium ion. We're using lithium ion because, as we know, Tesla has been using it extensively and to great effect. So we are trying to use the effect of lithium ion batteries. We can either use lithium ion batteries to store energy, or the flywheel can be used as a battery. Now let's compare them. The flywheel's rotation of 60,000 rpm creates gyroscopic effects upon the wind turbine. The energy that is transferred back and forth between the two MGUs is stored in the flywheel's rotational movement, which can then be used as a motor. So what flywheel is doing is converting the kinetic energy generated in the entire process to potential energy, which can be used later. And everything is got losses. Even this thing would generate its own amount of losses because of the initial charging of the flywheel and the batteries. And like in the case of flywheel, there will be flywheel spinning called standby loss, and batteries will have a float charge called trickle charge loss, as you can see. Now the but let's have the impact on pollution, because what we are trying to do is reduce the dependency on fossil fuels. Now batteries have got a lower carbon footprint because the energy consumed to operate the flywheel over its lifetime is greater, and the carbon emission from this energy is more than any carbon emission savings in raw materials or cooling. This was one aspect. Let's have a look at the economic aspect. A flywheel costs about $2,000 whereas cost of batteries for same energy capability would be $8,000. Massive difference. We can't use that much amount of money. Moreover, flywheels with large motor generators can push and pull energy out of the spinning rotors faster as compared to batteries. Now, this is one very interesting case which I came across of the use of flywheel, which I would like to talk about over here. Now, there's this St. Paul Island where which has been powered by beacon power. What they have done, fantastic innovation, is it is located in Alaska. What they have done, the same thing as we are trying to do. They are generating energy for the airport through wind diesel microgrid, same as what we are doing through wind and thermal energy generation. This energy, because they know there will be times when the wind won't be available in that much quantity, they are storing that energy into flywheels. The flywheel technology will stabilize and support the grid and is expected to increase diesel uptime by an additional 10% to 15%. So this It is decreasing the dependency of airports which use large amount of energy on fossil fuels by using the technology of wind and flywheels for storing energy. This is a huge innovation in the airports and is massively used. It has been commemorated everywhere. It is similar to us. The MGUK in our wind generation will generate energy from braking of wind blades. This energy can be stored in batteries or flywheels. In the thermal generation, the pollution created would be passed through the turbochargers and compressors of MGUH. This again will generate kinetic energy that can be converted into electrical energy. So all in all, let's think of this. We've got 6 ways of generating energy in an electric unit now with the implementation of this technology. The conventional energy generation technique, that is use of fossil fuels. We want to lower the dependency on that. The MGUK from wind turbines. The MGUH use of compressors and turbochargers to generate energy from pollution. The energy storage from flywheel or battery technology. The turbochargers for for venting in air from outside like air conditioners, and of course, like we traditionally have in contemporary practice, the power electronics in wind turbines. So this is my project on how we can generate energy in several different ways without affecting the earth and environment. I hope someday this will be implemented, because the technology implemented in Formula 1, if that can be done in such a minute scale, why can't we think of this of implementing at a large scale? Thank you. As you can see, this is the MGU and MGUH technology. Whenever there's braking, the braking, instead of engine, will have synchronous machine. So whenever there's braking, the braking will power the MGU. The MGU will power the PCU, that is convert the AC to DC, and that energy will be stored in battery. In Formula 1, they use that to drive the car. In our case, it will be used in applications or loads involved. Now, as you see, number 5 cores button, whenever we need energy, the cores, that is storage of energy from the batteries or flywheels, will be given to the grid, discharging inverted rotation, and more power will be produced in the grid as what we have. At the top you see 2 engines, which are the MGUH and MGUK turbocharger internal combustion V6 engine. These are all the components of Formula 1 at a small scale, but this is enough to generate enough energy. These big components, are big enough to generate energy for one day at a household. So why can't we use this to generate energy for every one of us in the entire world? Let's have a look. The most important thing, what here for economic aspects. What this will help in save 15% in fuel costs by reduction in dependency on fossil fuels. Now then again, there's this question that because of flywheel technology being expensive, so is the engine technology being expensive? Wouldn't that be exceed our amount? The thing is that is a capital cost and will only be implemented once, whereas this accumulates time and again. There will be reduction of fuel consumption and less CO2 emissions, definitely, because we are using 6 ways to generate power. That will be 5 other ways apart from the traditional method. The turbocharger ensures that more of the fuel is burned, producing more power per unit of fuel with less exhaust. It is expected to increase diesel uptime by an additional 10 to 15%, that is dependency on fossil fuels. Reduction of cost of electricity and heat to 40% of the original diesel-based generation cost. Because there are so many ways and there's only one capital cost is applied only once. Whatever cost we have after that are all maintenance cost. The advantages of the system: there will be 7 possible energy paths to keep providing energy to the grid rather than wasting it through exhaust and braking. There will be considerable increase in power output by using about 30% less fuel. Of course, we got so many ways to generate energy. One more thing with synchronous machines and turbines is that they generate large amount of sound. The noise is not good, and therefore they are mostly remotely situated. The use of turbochargers and compressors would help them, not to a large extent, but definitely to some extent reduce the sound. Recovery of at least 5 times of energy with different ways, yes, and because we are generating energy even when the wind is less. We are generating energy even during pollution. So yes, wind turbines peak power is nowhere near as high as thermal plant that has almost instantaneous torque. This is especially useful in turbocharged plants that often suffer from turbo lag, like difference in rotor and stator speed in synchronous machines. Using the MGU as a stator can fill the torque gap between the turbos pulling up and providing full boost. The recovery and reduction of waste heat not only conserves fuel, usually fossil fuel, but also reduces the amount of waste heat and greenhouse gases dumped to environment. No use of power electronics or maximum power point tracking in wind turbines by use of DQ control. We can avoid this and avoid the situations of voltage sags, flicker, high frequency harmonics. The power quality measurements of reactive power voltage sag behavior switching with respect to insertion of wind turbines into the grids can be highly minimized. Thank you so much. Have a great day.